Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. I'm doing this a day early because of some feedback I got from some folks earlier today, and I felt motivated to just knock this out tonight. I am recording it quite late, so I suspect that many of you, if not all of you, will not see this until sometime on Monday. But I do have some very strong opinions about the subject matter here, and it's my opinion only, and feel free to agree or disagree with it. And we are still friends, okay? So let's get started here. I've entitled this video Exposing the Clickbaiters. All right. So we have talked a lot over the 2.5 years that I've been doing this about deterministic model forecast. And basically all it is taking a look at one single computer model forecast and putting all of your eggs in that one basket. And that's all we could do for a good many years because we didn't have the computing power to do anything more than that. One thing you will learn about models, if you haven't learned this already, is that the initial conditions are absolutely critical to any model forecast being correct. If you don't know what the current state of the atmosphere is accurately, you have no chance of producing an accurate forecast down the road, because those errors at the beginning are only going to multiply and magnify with time. So if you take a look at this forecast here, which is the European Operational Model Forecast for the morning of January 6th, which is a Monday, you see that it has a large area, excuse me, of light to moderate snow covering much of North Carolina, southern Virginia, West Virginia, southern Ohio, eastern Kentucky, and Tennessee. Now, one of the general forecasting rules for a major snow event in North Carolina is you like to have a big area of high pressure over the northeast because it leads to cold air damming, and it continues to feed cold air down from eastern Canada and New England into the Piedmont of North Carolina. We don't have that in this situation. The main high is out here in the plains, and I'm always very suspicious of big snow forecasts when I see the high in that position. But nonetheless, that's what it's calling for. And if you zoom in even tighter, you see that it's laying down a blanket of about 4 to 5 inches of snow across much of central North Carolina, again on Monday, January 6th. Now, we have also talked about the fact that ensemble forecasting is the way to go. It's a 21st century forecasting solution. A lot of people are comfortable hanging on to 20th century science. I don't know why, but they do. And so the advantage of ensemble forecasting is now we have the computing power to change the initial conditions just slightly to 50 different extents, run all those models out. It's the same model, it's just different initial conditions. And then you see how much variance there is in those solutions. And if there's a lot of variance, it tells you that the atmosphere is very sensitive to those small errors at the beginning, and that you shouldn't hang your hat on any one single model forecast, that the uncertainty is quite high. However, if all the ensemble model solutions are similar, then it's telling you that the atmosphere is not terribly sensitive to those small changes at the beginning, and you have a higher level of confidence in the overall forecast as a result of that. Now, supposing that somebody has heard my rant over the years about misusing deterministic model forecasts and the need to use ensembles, and they take a look at something like this and they say, but Greg, I am using ensembles. And this bottom graph here is snow, and it's the ensemble mean of the cumulative amount of snow that's going to fall between now and the 13th of January. And that ensemble mean is 4.6 inches. And so, why are you criticizing me? I am using the ensembles, and the ensemble mean is a little over 4.5 inches. And so that's pretty impressive, right? Well, here's the problem with that, is that these 51 ensemble members are generating different systems that are on different tracks on different days. Okay? So one may be moving a storm just south of us on Monday and dumping a certain amount of snow. Another one maybe has a system a little farther south and east than that on a different day. And a third ensemble member has one a little north and west of that on yet a third different day. So you cannot look at a cumulative total of 51 ensemble forecasts when these different ensemble members have different systems in different places on different days, you can't do it, okay? And so what you can do is take a look at much, much shorter time periods, like 12 hours at a time. And so I went through a very painstaking process this afternoon of looking at all 51 ensemble members and split the forecasts up into 12-hour periods over a period of 10 days, okay? And so those are the numbers I'm going to share with you now. Before I get to those numbers, I want to talk a little bit about bell curves and percentiles, okay? We've used the example of a classroom of students, and they all take an exam. And if the test scores are evenly distributed, they are in the shape of a bell curve. Most of the test scores are in the middle. You have the people over here that bombed the exam, and you have the people over here that aced it, but they're basically on the tails of the bell. Most of the scores are in the middle. And so many times you can define that as the 25th to the 75th percentile of a given set of data, okay? So let's take a look at the European Ensemble System forecast from January 3rd during the day to January 5th during the day. Now, when you see January 3rd at night, that's 7 p.m. to 7 a.m. the next morning. So technically it bleeds into the 4th, but I think you know what I mean. It starts on the night of the 3rd, and we're going to call that the night of the 3rd. So we go from the daytime January 3rd to the daytime January 5th. The maximum ensemble member in terms of snowfall amounts over a 12-hour period, 0.1, 2, 0, 0, and 0.6. By the time you get to the 90th percentile, which means that 90% of the ensemble members are less than these values, it's all goose eggs. So we don't have to belabor this point anymore. Let's move on. And there's the 25th to the 75th, all zeros. All right, so now we go from the night of January 5th to the night of January 7th. And again, the maximum amount of any ensemble member for those 5 12-hour periods, 4, 3, 0, 0, and 4. The 25th to the 75th percentile, only the 75th percentile has anything above 0. For the night of January 5th, it does have a half an inch, and then 0.1 during the day on the 6th. Rest of them are goose eggs, and the 50th and the 25th are all goose eggs. So not exactly what you would call a mandate in terms of a heavy snow event. Now, let's move on ahead to January 8th during the day to January 10th during the day. Now it gets more interesting. The maximum ensemble amount is 8, 10, 15, 2, and 7. But by the time you get to the 90th percentile, which means that 90% of the ensemble members are less than these values, you're down to 0.2, 3, 1, 1, and 0.2. And by the time you get to the 75th percentile, only January 8th at night has anything, and it's 0.2. Everything else is goose eggs. And finally, the period from the night of January 10th to the night of January 12th, again, the maximum ensemble forecast, 4, 10, 7, 1, and 7.7. But by the time you get to the 90th percentile, it's 1.1 and 3 goose eggs. And the 25th to the 75th have absolutely nothing for all 5 of those 12-hour periods. Okay, so some key things to remember here. 51 ensemble forecasts. Oh, I think I have 4 asks there. I left out the C. Sorry about that. 51 ensemble forecasts for 20 12-hour periods. That amounts to 1,020 forecasts. 125 of them have snow amounts greater than or equal to 0.1 inches. And 0.1 inches is the definition of measurable snow. So the percentage is 12.3% of those 1,020 forecasts. The 12-hour period with the highest percentage of ensemble members greater than or equal to 0.1 is the night of Sunday. I should have proofread this a little better, huh? The night of Sunday, January 5th. 43.1% of the ensemble members have 0.1 inches or greater during that 12-hour period. And the next highest are on the day of Monday, January 6th, the next 12-hour period after the night of the 5th, and also the night of Wednesday, January 8th, 29.4 and 31.4% respectively. All of the rest are under 20. So, my conclusions, and again, these are my personal opinions. There's no reason why you have to agree with me or have to disagree with me. I'm just sharing my passion here with you. So, could a major snowstorm for central North Carolina be on the way? It could. The chance is not zero. That's not what I'm claiming at all. I'm simply claiming that I don't have enough evidence right now to support getting everybody in an uproar about a major snowstorm based on the numbers I just shared with you. Okay? The purpose of ensemble forecasting is to avoid getting locked into one single model forecast and putting all of your eggs in that one basket. That is risky at best, especially at long time ranges. Okay? And remember, the farther south you go, the more things that can go wrong with a snow forecast, okay? If you're up around Buffalo, a lot of things can go wrong and you can still pull it off, okay? At this latitude, with our proximity to the warm waters of the Gulf Stream, just a couple of key things go wrong and it's over, okay? And the other thing is, and I'll let you in on a little secret here, when I was at WRAL, we were the last station to expand our forecast from 5 to 7 days. Okay, I fought it like the plague, but we eventually gave in because the majority of the public demanded it. I had people tell me that on Sunday night when they watched the weather, they wanted to see the next weekend in that forecast, even if that forecast was unreliable. Okay, and that's the only reason we did it. I'm just as against it today as I was back then. Okay, but people want to see it, and so we put it up there. Okay. Unfortunately, some meteorologists, as well as non-degreed weather prognosticators, and there are several of those out there, are following in the steps of contemporary journalists. It's all about sensationalism, and it's all done to get eyeballs, okay? And if you think about it, journalism, news journalism, has pretty much gone the same way. I grew up in an era of Walter Cronkite and Chet Huntley and David Brinkley, where they reported the news and then you decided how you felt about it. Now, news organizations tell you their opinion, try to convince you to agree with them, and to view the other side as a bunch of demons, okay? So that's their way of sensationalizing the news and trying to get eyeballs, and we sort of have an analogy in the weather department doing pretty much the same thing. So I feel comfortable waiting until I see the, quote, whites of its eyes before forecasting a major snow event. If by the time we get to Friday and Saturday, that a lot of the ensemble members are in agreement that we're heading in that direction, then I will make the necessary adjustments at that time. I will not be able to claim that I was the first to call for it because I won't be, okay? In fact, my goal is not to be the first. I want to be right as much as possible. And based on the evidence that I just shared with you tonight, the confidence level is simply not there to be able to talk with confidence about a major snow event in central North Carolina more than a week out into the future. All right, sermon over. I will get off the pulpit. I hope you found that at least mildly interesting. That is bonus weather video number 1 for this week. The next one will be coming up on Wednesday, and of course, the next daily weather update will be coming up tomorrow afternoon/evening. Have a wonderful Sunday evening if you're still up, or have a wonderful Monday if you see this tomorrow, and we'll talk to you soon. See you later, everybody.